This is the second part of the 11.41 lecture notes, Calculus with Polar Curves. All right, so here are the steps for finding slopes of polar graphs. First, write the curve parametrically. X is r cos theta, y is r sine theta. Second, use the parametric slope formula. So we know dy dx is dy dt over dx dt if the parameter is t. So this is the same thing, except now the parameter is theta. Your book has a special formula involving f of theta and cos theta and sine theta. Don't use that. Just use this and what we already know. It's much easier. Then if you want to find a tangent line, you go a little further. You find the slope at the specified value of theta. You find the point on the curve, x naught, y naught, and then use point slope. So here we go. Find the slope of this circle, r equals 4 cos theta, at the given thetas, and then find a Cartesian equation of the tangent line. So, step 1, use x is r cos theta, y is r sine theta. So r is 4 cosine theta. So we want r and then cosine theta. So that's 4 cosine squared theta. Y is r sine theta, which is 4 cos theta sine theta. Okay, that's going to be the first step always. Don't skip that step. 2, now we're going to find dy dx, which is dy d theta over dx d theta. All right, so dy d theta. I need the product rule. The derivative of, I'm going to let 4 cos theta be my f and sine theta be my g. So the derivative of 4 cos theta is negative 4 sine theta. So I'll get negative 4 sine squared theta. And now I want to add on f times g prime. The derivative of sine is cos, so plus 4 cosine squared theta. All right, in the denominator, dx d theta, I'm just going to use the chain rule, bring a 2 down, 8, leave the inside fixed, cos theta, multiply by the derivative of the inside, which is negative sine theta. Now, let's factor out a negative 4 from the top and the bottom, just to clean it up a little bit. So if we factor negative 4 out and cancel it with the negative 4 in the bottom, we'll get sine squared theta minus cosine squared theta divided by positive 2 cos theta sine theta. Okay, so now we found the slope at any value of theta. If we want a tangent line at theta equals 0, then we're going to need the slope at theta equals 0. So we want dy dx at theta equals 0. So I put 0 into this slope formula. And I get 0 minus 1 over the denominator, I get 0. So negative 1 over 0 is undefined. What does that mean? It means I have a vertical tangent. Vertical tangent. So I need the point or a point on my curve, so I need the x naught, y naught. Okay, so I'm up here at step 4. Find x of 0, y of 0. Now you've got x and y up in step 1. X is 4 cosine squared theta. So we want 4 cosine squared of 0 is 1, so that's 4. Then y is 4 cos theta sine theta, sine of 0 is 0, so 0. So I want a vertical line through 4, 0. That's x equals 4. And there it is, x equals 4. And you can see the tangent line is indeed vertical there. All right, let's do the exact same thing except at pi over 6. Now, we've done a lot of the work. Steps 1 and 2 do not need to be redone. X is still 4 cosine squared, y is still 4 cos theta sine theta, and dy dx is the same. The only thing that's going to change is steps 3, 4, and 5. All right, so for step 3, I take this slope formula here and I put in pi over 6, which I've already started for us. Okay, sine of pi over 6 is a half squared is a fourth. Cosine of pi over 6 is root 3 over 2, so if we square that, we get 3 over 4. And then in the denominator, I have 2 times a half times root 3 over 2. So if I clean this up, on top I get negative a half, and on the bottom I have root 3 over 2. So this simplifies to negative 1 over root 3. My x naught, y naught, I take x and evaluate it at pi over 6, and y evaluate at pi over 6. That gives me, okay, cosine squared of pi over 6, that's root 3 over 2 squared, which would be root 3 over 4 times 4 is root 3. That's not right, is it? Because I squared, I'll go a little slower. We have 4 times root 3 over 2 squared, and then y is 4 root 3 over 2 times a half, so that's 3 comma root 3. All right, that's better. Now I use point slope. Y minus root 3 is the slope, which is negative 1 over root 3, x minus 3. And then I do a little bit of cleanup. That's y equals negative 1 over root 3x. Then I distribute, I add 3 over root 3 is just root 3, and then add another one, so 2 root 3. All right, and so that would be at pi over 6, be about here, and so there's our tangent line right there. Where on the interval from 0 to pi is the tangent line horizontal? I'm just going from 0 to pi because I remember the period is 0 to pi, so I get the whole circle from 0 to pi. It looks to me like we're going to find 2 values of theta because the tangent line is horizontal in 2 places. So a horizontal tangent has slope 0. A vertical tangent has slope undefined. So if we wanted to find out where the tangent was vertical, we would set the denominator equal to 0. But if we want to find out where the tangent line is horizontal, we want to set m equal to 0. Now a fraction is 0 if and only if the numerator is 0. Sine squared theta minus cosine squared theta is 0. So sine squared theta equals cosine squared theta. So sine theta is plus or minus cosine theta. All right, well, on the unit circle, sine theta equals cos theta at theta equals pi over 6, sorry, pi over 4. And then they're opposites at 3 pi over 4. So those are our 2 angles that correspond to these horizontal tangent lines. Okay, the next one you're going to do. So I want you to pause the video and do it completely, and then come back and watch me do the solution. While you're gone, I'm going to start filling in some stuff so you don't have to watch me writing down the whole dy dx. All right, I'm back. I started this out. I've got x and y. X is r cos theta, and y is r sine theta. And then using the slope formula, I've got dy d theta over dx d theta. Notice all my minus signs, pulling the 4 out. You cannot in any way combine, sine 4 theta and sine theta. The argument is different and you can't just pull the 4 out. So this is as good as it gets in terms of simplification. You're just gonna have to leave it like that, which is fine. All right, so let's continue now. Find the slope at theta equals pi over 4. So m is this expression above, dy dx, at pi over 4, which is, okay, got to be careful here. Some thetas are multiplied by 4 and some aren't. So if we multiply pi over 4 by 4, we get sine of pi up here. So sine of pi is 0. Then we get plus cosine pi, which is -1, times cosine of pi over 4. So that'll give us -1 over root 2. Downstairs, we have 0 minus -1 over root 2. So I get -1 over root 2 over +1 over root 2, which is -1. All right, so there's the slope. And now I need x0, y0, because I want an equation for the tangent line. So that's going to be x at pi over 4, comma y at pi over 4. Now x and y are up above in step 1. So x at pi over 4. So that's going to be cos pi times cosine of pi over 4. That's -1 over root 2. And then y at pi over 4 would be cos pi sine of pi over 4, which is also -1 over root 2. Okay, so point slope. Y plus 1 over root 2 is negative x plus 1 over root 2. Y equals -x minus 1 over root 2 minus 1 over root 2. So minus 2 over root 2 is the same as minus root 2. All right, graph that on the curve. So the point, -1 over root 2, -1 over root 2, that's here. The slope is negative, looks like that. Now you might say, wait a minute, when theta's pi over 4, shouldn't I be up here? And that's a good question. And the answer is no, because take a look at the original curve. Let's find r when theta's pi over 4. R is cosine pi, which is -1. So to plot the point -1 pi over 4, since r is negative, we go to the angle pi over 4, but then we go to the opposite quadrant. So we are indeed down here in quadrant 3. Okay, so now I think there's one more for you guys to do. Yeah, find a Cartesian equation at 3 pi over 2, graph it on the curve. So what I did was just put 3 pi over 2 into our formula in part A for slope. Okay, yikes. All right, hopefully this won't be as bad as it seems. Well, no, it's not, because cosine sine of 6 pi is 0, so that's nice. We get 0, and then cosine of 3 pi over 2 is 0. So 0 plus 0 is 0. And then in the denominator, we get 0 minus -1. So that's 0 over 1, which is 0. If 0 is on the top, slope is 0. So now we know we have a horizontal tangent. So horizontal. So the tangent line is going to be y equals something. And we just have to find the something. So we need the point on the curve, x0, y0. Okay, that's going to be 0, -1. So a horizontal line going through 0, -1 is y equals -1. And so let's graph that on the curve. The Cartesian point is 0, -1. That's here. And the slope is 0, so it's horizontal. All right, we'll do some more of these in the section 11.4 part 2 lecture notes, but pretty much you now know all the content of 11.4. Here are your symmetry tests, but you don't memorize them and actually don't use them. Use the graph to determine symmetry.